Okay, so in this tutorial we will be learning how to perform the Brazilian test using the split Hopkinson pressure bar equipment. At first we will create the geometry. The geometry will consist of a specimen, incident bar, transmit bar, and a projectile. The specimen is 25 millimeter thick and 100 millimeter diameter. Now we will add the incident bars, transmit bar, and the projectile. Incident bar is 1 inch in diameter and 3950 millimeter in length. The transmit bar is 3000 millimeter in length and 1 inch in diameter. The projectile is 1 inch in diameter and 1200 millimeter in length. Now we will first add the incident and the transmit bars. Sure to merge, uncheck merge result, and now in a similar way we will add the projectile. Again, make sure to uncheck merge result. Now we have the 4 parts required for the simulation: the projectile, incident bar, specimen, and the transmit bar. We will now save it as a step file to import. Okay, within ANSYS we have two options: the explicit dynamics autodyne solver or the LS-DYNA solver. We will use the explicit dynamics solver. First we will create the material, which will be concrete and the steel. We will delete the default material and create a new material based on the properties. We will use isotropic elasticity. These properties I am entering are from our tests in the lab. We will use the principal stress, the first principal stress, to initiate failure. We will use a very large value for maximum shear stress so that the specimen does not fail under shear loading. The fracture energy value is a guess at this point. We will also turn on erosion. For the steel, we will just use a linear elastic material without any failures. And now we are ready to load our geometry. We will now switch to the design modeler. Okay, now within design modeler, we will click generate and share topology. Share topology will allow the mesher to have common nodes at the interfaces. It will result in less interpolation and more accurate simulation. We will now rename all 4 parts of the geometry. Specimen is the specimen, incident bar is incident, the projectile is the striker, and the transmit bar is the transmit. We will then click generate and close. Okay, inside the ANSYS, on the outline plane towards the left, we will move from top to the bottom. So the specimen will be concrete. We will assign the materials. The incident, striker, and transmit will be steel. We will now recheck the materials to make sure everything is okay. We will delete the default connections and body interactions and create a new frictionless body interaction between all the parts. For the mesh, we will use 5 mm for the purpose of this tutorial. This value is ultimately chosen based on the mesh independent study. The mesh has to be uniform because the ANSYS manual says so. And now we will apply a boundary condition. We will constrain the free end of the transmit bar in the direction of the projectile motion. And we will now apply a initial velocity to the projectile itself to create the initial pulse. We will now set how long we want the simulation to go, and we will turn on the material failure, and we will say 100 time steps. Now we are ready to solve. Before that, we will need to look at the maximum principal stress inside the specimen, and we save that. Now we are ready to solve, and then we press the solve button and the simulation will begin. Now the simulation is complete, and we will look at the results. We will just adjust the scale and zoom, etc. some things. We will use a script to rescale the legend. We will use maximum value 16.5 MPa because that is what our input was. We will get rid of minimum and the average parts because we are only interested in the maximum tensile strength. And we will just play the animation. Thank you very much for watching. Bye.